learning about energy and health. Enjoy the video!
What is nuclear energy and how does it work? Since the beginning of the Industrial Revolution, the demand for energy has increased dramatically year after year. Today, the majority of this demand is met with the combustion of fossil fuels. With the recent disaster at Fukushima as well as the ever-present effects of the events at Chernobyl and 3 Mile Island, nuclear power has lost some of the enthusiasm that once surrounded it. Because of the rising costs and harmful effects of the environment caused by fossil fuels, people are looking for ways to replace our dependence upon them. While renewables such as hydroelectric, solar, and wind energy have proven to be worthy replacement, they are still a ways off from meeting our needs. Nuclear, on the other hand, has all of the technology required to be used on a large scale. Now, let's see how most nuclear power plants actually work. First, we have the fuel, usually uranium, which must be mined, enriched, and then formed into pellets that are placed in rods within the reactor. The atoms of uranium undergo a controlled chain reaction which emits heat. Pressurized water around the reactor vessel is heated and circulated through pipes in a steam generator, which produces water vapor that spins a turbine attached to a generator. After leaving the turbine, the steam is condensed so that the cycle can continue. The main concerns surrounding nuclear energy are safety, waste management, and total expense. Contrary to popular belief, nuclear is among the safest sources of energy that is currently in use. Despite the seemingly huge impact reported by the media, there have been no deaths as a direct result of the meltdown at either Fukushima or 3 Mile Island. Even in the case of Chernobyl, the total number of expected deaths is quite low. In comparison, deaths due to the use of coal are over 10,000 per year in the US alone. However, deaths are not the only impact which an accident can have. They can force people out of their homes and change the land around them for a very long time. So then, how can nuclear play into our energy future? Combined with renewable sources, nuclear allows us to enjoy our energy needs without the impact on our environment that is coupled with fossil fuels.
Hi, I will be explain about pollution of atmosphere. Let's roll it.
Did you aware of the effects of air pollutants on your health? First of all, you may already have had some breathing discomfort or painful eyes. And the thing that we will be focusing on this video are firstly, particulate matter PM, second, ozone O3, third, nitrogen oxides, and lastly, sulfur dioxide. However, some of the pollutants are the direct results of human activity. For example, the burning of fossil fuels in the power station or cars. Next, particulate matter is a mixture of sulfates, nitrates, ammonia, sodium chloride, carbon, mineral dust, and water. It consists of a complex mixture of solid and liquid particles of organic and inorganic substances suspended in the air. These particles are identified according to their aerodynamic diameter as either PM10, particle with an aerodynamic diameter smaller than 10 microns, or PM2.5. These have aerodynamic diameter smaller than 2.5 microns. In comparison, the average size of human hair is 60 microns. PM2.5 are more dangerous since, when inhaled, they may reach deep into the lungs and interfere with gases exchange. The health of particulate matter are felt in both the developed and developing world. Chronic exposure to the particles contributes to the risk of developing cardiovascular and respiratory diseases such as asthma as well as lung cancer. Ozone O3 absorbs harmful UV rays from the sun in the upper atmosphere and can help prevent the increased risk of skin cancer. However, ground-level ozone causes problems. It does so photochemical reaction, which is triggered by the absorption of light. The reactions between nitrogen oxides and volatile organic compounds lead to the formation of photochemical smoke and ground ozone. You see this more often in the summer, and it can appear as an orange-brown haze over a city. This smoke, included in the ground ozone, causes breathing problems, can trigger asthma attacks and lead to the lung diseases. Next, nitrogen dioxide emissions come from cars and factories where fuels are combusted. You may recall oxygen forms about 21% of our atmosphere, while nitrogen forms 79% in a hot engine. A tiny amount of nitrogen atoms join with oxygen atoms to form mixtures of nitrogen oxides called NMX. Studies have proven that there is a causal relationship between the symptoms of bronchitis. Respiratory disease been seen in children with asthma as a result of long-term exposure to this pollutant. Finally, there is a sulfur dioxide. Can you think how this chemical might be formed? The correct answer is that any sulfur combusted in the presence of oxygen, typically coming from fossil fuels, which naturally contain tiny amount of sulfur, and also the smelting of mineral ores, lead to the formation of sulfur dioxide. In turn, these pollutants affect the respiratory system and cause irritation of the eyes. If you breathe this in, you are more likely to cough or scream, or mucus will be a higher risk of developing chronic bronchitis. In summary, all are causing unnecessary death, especially where the emissions of these pollutants can be avoided for the use of catalytic converters in cars and by scrubbing of power station gases.
Hi, I will explain about chemical pollution. Let's check it out.
Water pollution. In this video, we examine the many ways the substances mankind throws away have polluted lakes, rivers, and even the ocean. The United Nations estimate that around 10% of the world's people do not have access to clean drinking water. That's over 700 million people. The main problem with is untreated water is that it can carry diseases such as cholera spread through untreated human feces. This is particularly serious in shanty towns near big cities and in refugee. Rivers and streams can also be polluted with diseases from water coming from badly managed rubbish dumps. But human sewage is not the only substance that pollutes our water supply. Most of the other substances humans allow to escape into stream, rivers, and the oceans are more dangerous to natural ecosystem than to us directly. Chemical fertilizers are much more soluble in water than organic manure-based fertilizer, so heavy rain can wash them into streams and lakes, causing eutrophication. The fertilizer causes algae to grow very fast, forming a mat on the lake surface. This blocks sunlight from the vegetation deeper down, which dies. Bacteria then feed off the dying vegetation and use up the remaining oxygen supply. Once the oxygen has gone, all animal life dies. The lake ecosystem is destroyed. If heavy metals such as lead, mercury, and cadmium get into rivers and lakes, many animals will die. In Minamoto, Japan, a polluting mercury fungicide factory was closed in 1968, yet people there have continued to be affected by the mercury poisoning, the so-called Minamoto disease, ever since, because the fish caught locally in the bay still have traces of mercury in them. Nowadays, the use of mercury and cadmium in fungicide has been largely replaced by copper and organic compounds. The removal of lead from petrol begins in the 70s when it becomes clear that lead poisoning causing metal defect was caused by the lead compound added to petrol to make it burn more smoothly. It has taken 40 years since then for United Nations global ban on the sale of leaded. The last six nations complied in 2013. Radioactive waste is normally stored above ground in water tanks, waiting for more permanent underground storage where it has been safe for millions of years. There are fears that this underground store could fail and contaminate water courses. Currently, small amounts of radioactive material are allowed to wash out to sea on the basis that it will become so diluted that it will make no difference to the natural background radioactivity in the ocean. Following a nuclear disaster like 5 Mile Island in 1979, Chernobyl in 1986, or Fukushima in 2011, Watercourses and the ocean can become dangerously polluted with radioactive waste. During mining and drilling operations to extract mineral from the Earth's aquifer, which are the underground watercourses, can be polluted. Huge amount of plastic thrown away from ships and washed out to sea from rubbish dumped on land have ended up floating in huge islands of waste, causing a serious threat to fish, seabirds, and other. The so-called Great Pacific Garbage Patch is estimated to be half the size of Europe, and there are 4 others. Coal and oil-fueled power stations have been responsible, more so in the past, for causing acid rain which devastated many North European new lakes in the 16th. Fossil fuel and nuclear power stations need large amounts of water for condensing the steam which drive their turbines. This water is usually cooled on site in the great cooling towers that dominate the skyline of power stations. Even so, the water will be returned to the river or sea warmer than before, and this can upset the river or sea ecosystem. Although not material pollution, this waste heat is a pollutant. So, to summarize, there are many ways mankind is polluting the rivers, lakes, and seas. Perhaps the most serious causing millions to become ill or die is pollution by human sewage.
Hi, I will explain about global warming and greenhouse effect.
Gas molecules are absorbed by the thermal radiation, which is sun, that affect the climate change. The greenhouse gas effect was in one of the gases molecule, which consists carbon dioxide, methane, nitrous oxide, and so on. The effect of the greenhouse gases effect will rise the temperature of the surface of the earth that can cause global warming. Global warming has become a growing issue in the past year of decades.
That the combination of sea level rise and storm surge would flood the 9/11 memorial site, and people said, what a terrible exaggeration.
Hurricane Sandy slammed into New York City last night, flooding the World Trade Center site.
Storms get stronger and more destructive. Watch the water splash off the city.
So, everyone, let's watch what is the greenhouse gases effect that can cause the global warming.
Greenhouse effect. The greenhouse effect is a natural process in which certain gases, known as greenhouse gases, trap heat that radiates from the Earth's surface. In fact, a greenhouse is a construction of transparent walls and roofs in cold countries to provide adequate heat to the soil and plants. The solar heat energy penetrates the greenhouse, but it is prevented from escaping, and thus heat remains within the greenhouse, keeping it warm. The greenhouse analogy refers to the fact that greenhouse gases function much like the glass panels that trap heat inside the greenhouse. It is a naturally occurring phenomenon wherein certain atmospheric gases, such as water vapor and carbon dioxide, regulate the radiant energy balance of Earth, thus making it habitable.
So now we know that the increasing of the greenhouse gases will affect the climate change due to global warming.
The greenhouse effect. When you see a beautiful, fat, full moon, do you ever imagine what it'd be like to be up there, standing on its surface? Well, for one thing, hot. About 120 degrees Celsius hot. But 14 days later, at new moon, you'd be in the middle of the long lunar night, and the temperature would have plummeted to around minus 170 degrees. On average, the moon and Earth are the same distance from the sun, so they get the same amount of solar energy. But here, the average temperature is 16 degrees Celsius, while on the moon, it's more like minus 80. The Earth has a much smaller range of temperatures too. -88 and +57 are the lowest and highest on record. So, why the difference? The answer is the atmosphere. It protects us from a lot of the sun's energy, but also traps some that gets through so that, for example, at night, temperatures don't fall that much, especially if it's cloudy. The energy that comes from the sun is electromagnetic radiation in a broad range of wavelengths. The upper atmosphere absorbs most of these wavelengths. Visible light gets through, but a third of this reflects straight back out again, mainly off clouds and ice. So only half of the energy heading for Earth gets to warm its land and oceans. Rock, soil and water heated by visible light re-emit the energy as low-energy infrared radiation, heat. This can pass through the oxygen and nitrogen in the air. But some gases, the so-called greenhouse gases, carbon dioxide, methane, nitrous oxide and water vapour, have molecules with structures that make them absorb the radiation. Struck by an infrared wave, they vibrate strongly before releasing the energy as a new infrared wave. This can shoot out in any direction, towards space, down to Earth, or out sideways. But in every case, there's a good chance the wave will strike another greenhouse gas molecule and change course again. Although greenhouse gases typically make up less than 1% of the air, they're in a layer of atmosphere 6 kilometres deep. Not much escaping radiation makes it through without encountering at least one greenhouse gas molecule. Over the entire planet, the result of this giant pinball game is that heat stays close to the Earth's surface for longer than it otherwise would, keeping it warmer. This is the greenhouse effect. Without it, Earth would have an average temperature of -18 degrees Celsius, which is better than the moon. But, I think you'll agree, not as good as what we've got.